Welcome to our third example of homogeneous. So let's do it. Please make sure you watch the previous two examples of homogeneous. So here, the differential equation written in mdx plus ndy format. So there are different way of writing differential equation, and we talked about this before. So here you can easily write it down by solving for y prime. So you can divide both side by dx. So dy over dx, that's just y prime. And of course, 0 divided by dx is 0. So that doesn't change. And if we solve for y prime, um, by moving this to the other side and then divide both side by x square, just simple algebra, you are going to end up with y square plus xy or yx, doesn't matter, divided by x square. So we just rewrite in this way. So it's more familiar to us for homogeneous. And of course, we have to express the right hand side in terms of y over x. If we cannot do that, that means it is not homogeneous. But in this case, I can simply distribute the x square. So I can simply distribute the x square under each term, and that will do the job. So let's rewrite this. So I can write y prime equal to, now y square over x square, I can just write as y over x parenthesis square, plus here one of the x will cancel out. So I'll end up with y over x. So indeed, it is homogeneous because the right hand side is written in terms of y over x. So now we do the same substitution every time for homogeneous. So v equal to y over x, cross multiply, y equal to vx, take the derivative of both sides with respect to x. So dy dx equal to, here product rule, so dv dx times x plus v times the derivative of x, which is 1. So it's always, so this part on the left is always the same thing for every homogeneous. So just a repetition. So of course you're going to substitute in place of y prime. I'm going to substitute this, and in place of y over x you substitute v. So that goes in place of v. So let's do that. So I end up with, so in place of y prime, I copy dv dx times x plus v equal to, in place of y over x, I substitute v. So v square plus v. I can cancel v from both sides, make things very easy. So that will be dv dx times x equal to v square. And this is actually separable in terms of v and x. So v play the role of y. V here is the unknown function. Of course, when I say v is a function of x, of course, right? Okay. So let's move it around. So I can divide both sides by v square to move it in this side, and I can move x over dx on the other side by reciprocal. If you remember, flipping, right? We did this type of technique on the last example. So let's flip around. So you can also think v square over 1. So when I move it to the other side, I flip 1 over v square dv. And when I flip x over dx, I get dx over x. but I can write that as 1 over x dx. Taking integral of both sides. Don't forget this 1 over v square is actually v to the power negative 2, right? So don't forget that. Let's take the integral. So is v to the power n plus 1, remember the formula, over n plus 1, plus c, but we're going to add c. All the c is going to be moved toward the right hand side. So we're going to add c at the end on the right hand side, equal to the integral of 1 over x is ln of x plus c. So let's try to simplify. So this is negative 1. So this is just negative v to the power negative 1. And of course, you are going to, I can rewrite this as negative 1 over negative 1 over v. V to the power negative 1 is 1 over v. Finally, don't forget to substitute back. Remember, v is equal to y over x. So make sure I have to substitute this back at the end. So I get this. And of course, 1 over y over x, you can just flip around. So you get x over y. So I get negative 1 over y over x, it's just x over y. So I can cross multiply both sides. So if I cross multiply, so I get, so if I multiply this way, I get y times ln of x plus c equal to, if I multiply this way, I get negative x. So I'm just moving this negative on the top. Let's just move around everything in one side. Maybe I can move this to this side. uh, I can also multiply this out like that. So I get y ln x, absolute value of x, plus cy plus x equal to 0. So that will be my implicit general solution. And don't forget the absolute value is very important. Whenever you have a ln, make sure you have the absolute value. That is actually important. You can leave it like this. Now c here is the parameter, and it's always a good idea to use GeoGebra. But before that, can you actually make it explicit? Can we make it explicit? This is actually, it's not that hard to make it explicit. So let's actually make it explicit. So whenever you can make it explicit solution, in other words, you can solve y in terms of x, please do that if it is not very hard. So here you can see that from these two, I can factor out y. And I can move this x to the other side. And then finally, I can write y, dividing both sides by this factor. I get negative x over ln of x. Oops, sorry. Let's write again. I get ln of absolute value of x plus c. And that will be an explicit solution. Isn't that beautiful? Okay, so in this case, we actually make a general explicit solution, which is actually rare in differential equation. To find explicit solution, it's not all, most of the time you probably cannot do that, or even if you can do it, it's very, very hard or difficult. Let's visualize this. I'm actually going to graph the implicit one in the GeoGebra. So let's actually uh, graph it. Let's see what I get. So I'm using GeoGebra. So you start by entering the parameter C, hit enter, and by default C will go from -5 to 5, and then you simply type the implicit general solution. So y ln of x plus cy plus x. So let's see if you can do that. Y times, oh, not t, y times ln of x plus cy plus x equal to 0. Oh, see, amazing. And then of course you can move around. So for each value of c, so if I fix here, so at this point my c is 0.9, that's a graph of a solution. That's another graph of a solution. So each one is a solution to our differential equation. So for each value of c, I get a solution. And I can zoom out to see the big picture. So there are three parts of the solution, right? And they merge onto one part as c become larger. So you can play around with this GeoGebra. It's always a good idea to play around visually, so you get an overall picture of the general solution or the nature of the general solution. So it looks like somewhere in here there is a critical value of c. Looks like probably somewhere here where it's connected. So at some point the graph is actually connected to one single graph. Thank you very much, and always remember, you can do it. Always believe in yourself. Bye bye.